Systems of linear equations or linear inequalities are the same as linear equations, only you have to remember, right, if I have this or this, greater than or equal to. Greater than is like a dashed line. Hopefully this is bringing back some memories of inequalities. And then greater than or equal to would be a solid line. And then greater than also means that you shade above the line. And conversely, if I have less than or equal to, right, this is also a dashed line. This would be a solid line. And in this scenario, you shade below the line. So systems of linear inequalities consist of basically one or more linear inequalities that have the same variables, namely x and y. Solution of a system of linear inequalities is all the ordered pairs that make all the inequalities in the system true. And here's some examples. So in this scenario, this line right here, right, you have essentially everything above this line is shaded, right? And then in this line, everything above this line is shaded. And the solution that's above both lines, right, is essentially this region right here. Let me pick a different color. Right, where both conditions are satisfied, right? We're above the purple line and we're above this other line right here. And that's the part that's crisscrossed. So then we have to ask ourselves, if you can still see anymore with the colors, is the point 6, 2 part of the solution set? So I find 6, that's in here, 2, that's in here. So yes, let me erase this so you can now see. Essentially, we're talking about this region right here. Satisfies both conditions. And 6, 2 is right in there. So yes, right? Determine if a given point is a solution. In this case, 6, 2 certainly is. How about negative 2, 4? So negative 2, 4 is right in here. So that's a no. What about 2, negative 8? That's down here. That's a no. And 0, 8. Right up there. That's a yes. So basically, for this ordered pair, it's true. For this ordered pair, it's true. And these two would be false. So in this second scenario, the answer is above this line, shaded above this line, and also shaded below this line. And when I do that, you can see there's only one area that satisfies both conditions. So I'm going to erase these colors for the moment. Right, and now we have to ask ourselves, you can tell there it's the darkest of the 3 or 4 regions there. Is the point 2, negative 4 within the darkest shaded area? So I find 2, go down negative 4, and it's right there on the line. But what is that line? That line is a dashed line, right? So dashed line would mean it's not part of the solution, so no. That point actually would be false in this system. If I plugged in this value for x and y, it would be false for the system. How about the 0.44? That's right there. That's definitely true. -6, 0, be over here, again on the shaded line, or on the dashed line. And dashed lines mean are not part of the solution set, so this would also be false. And what about the 0.04? That's on the line, but you can tell that the line there is a solid line. And solid lines, if it's on the line, is a true statement, and it's part of the answer set because the line is solid. So there's some examples from the first page, essentially about what we're trying to figure out here. And let's move on to the second page. So your homework is mostly like these examples, where you're graphing two lines and you're trying to shade the correct region. So let's take a look at some examples, and remember you're going to need your line in this kind of format, except with inequalities it's like this, right? And inside the box could be greater than, less than, or greater than or equal to, and less than or equal to. So you could have one of those four things there, but then everything else is the same. This m is still the slope, this b is still the y-intercept. So let's see here. If I have the statement x is greater than 2, that's the line here, and the line will be dashed because it's not greater than or equal to. And in green here, if x is greater than 2, that's this region. And now in a different color, I have y is less than or equal to a -1/2 x minus 2. So my starting point is the point -2 on the y-axis. It's a line that's running downhill because my slope is negative. And it's down 1/2. And 2/4. So that's essentially this line right here. And then the line itself, that's less than or equal to, so the line is a solid line. And less than means shade below the line. And your answer set, at least that satisfies the system, will be this region, essentially where both conditions are met, right, from here to here. And I'm just circling it, so you can see right in this part in here only one of the line's condition is met. In this part only one of the line's conditions are met, but where they both overlap they are both met. So that's the key critical part of understanding systems of linear inequalities, is you're looking for the region that's shaded by both lines. So let's try another example. We have, I'm going to do this line in that color, and we're going to start at -5, which is right around here, and it's a positive slope, so it's running uphill, and it's running up 1/2, or 2/4. So it would be right around here, right around there. And I don't particularly like the way these graphs are, the way they're numbered, but your homework at least is not numbered this way. So, and then it's going to be less than or equal to. So it's this area below the line that I'm shading for that line. And now let's do this one. We're going to start at positive 12, which is way up here. And this has a slope of negative 2. And so I'm going to go down 2 over 1. Or down 4 over 2. So that's going to be like here, 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 there, and there. So we've got this line in green. And they're both solid because the symbols have that less than or equal to or greater than or equal to. And this is going to be the region above the line. And you'll see it's only this small sliver right in there that's actually true for both. And one more example. This one starts at negative 4, and then it goes up 4 over 5 or 8 over 10. So 2, 4, 6, 8, 10. And then it's a positive slope, and this is essentially the line here. And it's less than or equal to. The line is solid, and it's the region underneath the line. This other line I'm going to do in green. I'm going to start at negative 8 is its y-intercept. It has a slope of positive 2, 2 over 1, or 4 over 2, which looks something like this. And it is actually a dashed line, so let me undo that. It's dashed because there's no equals sign, so it's going to be dashed. And then it's also below the line. So essentially, only the area where they're both shaded, which is basically, like from here to there, all in here is true for both. And those are the regions you're trying to figure out when you're graphing these things in the homework examples.